That's getting pencil.
No problem. Okay, so we're gonna go over this.
Do we have
And
to
then-
do number 11 or no?
Yeah, you should have tried 11. You could have done it.
It's really easy. I just
That's good.
want to do it.
And then we'll do the problems like 12 and 13. We'll go over how to do them.
We're going to do 12.
Go ahead. Always something.
May I have your attention, please? The media center will be closed after school today. Attention students going to the homecoming dance. Photo ID is required by all students attending Friday's dance. School IDs will be accepted as well as passports, licenses, etc.
I'm going to bring my passport.
Freshmen and students new to Seneca may show ID from their middle schools or previous high schools. Thank you.
People from middle school are going?
Yeah, my date.
If you're a freshman, you haven't gotten your ID yet. I'll just
Comment. Who's been bringing the passport?
Who has a passport?
I do.
I have a passport.
I would too. If you haven't traveled abroad, why would you
I
have a
haven't
passport?
Right.
My passport doesn't look anything like me.
You have a passport? But you've never been abroad? Expired. Oh, that's the best.
Mine expires next year.
Whatever. And then tomorrow and Friday, as we're getting away with murder, we are going to like really review. So we could have the test on Friday. We really could.
No, we really couldn't.
We really could.
Really couldn't.
But I'll make it Monday. I know.
Make it Monday.
Just means I have more time to make it more creative.
Mostly just
No,
What's that?
son. No.
It's possible that I won't. I'm reading a good book right now. It's called The 19th Wife. It's about like the Mormons and the firsts.
Yeah, tell me about it.
And like polygamy and stuff. It is, yeah.
That sounds entertaining.
You might want to convert. It's really interesting. It's like it's a fiction, but it makes you feel like they have like excerpts from newspapers, but it's fiction, so it makes you feel like it's real. It's really weird. It's good. It's very good. Because I just finished that second Hunger Games book.
Everyone
They're
said
kinda- that
everyone said the
second-
third sucked.
Yeah.
The second one was okay. I gotta tell you, the ending. Come on, really?
I think of the first one. sucked.
Not spoiled.
What, to read the third? Like, yeah, but then like the way they ended it all, it was just like so science fiction. It was too much, but whatever. All right. Would it be easier if I just wrote these answers up? Probably would.
Yes.
Okay, so number 2. I don't know what order to go in here. So impressive.
Oh.
It's all out of order.
Yeah, you're gonna be out of order.
But essentially, I'm correct.
Whoops. I need out of order. This is A. Wait, so no arrow then? Right. Alright, what was the odd one that we didn't
7.
do? 7.
About.
Oh, wasn't that like Affinity? It was awful.
Why not?
And then
Sure, I can. It's the English language works.
Sorry.
number
Here are the
1, 10
answers.
to 2.
And 6 and 8.
You know what?
Okay, so negative line 3,
Just do them all.
square,
Should we do them all?
blah, blah, blah. That's 8 and then 6.
You get a yay or nay?
That's 10.
Okay, so we're really having trouble, right?
And then
No, it's just we're all having
7
trouble with
is just
different
1.
problems.
over the thing, and 11.
So
There's
everyone's
2
gonna fail,
ways
but for
to
different
writing it,
reasons.
Yeah, that's what we're saying.
just like that.
Class.
And you can pause at any time.
Great.
Sorry about the glare.
Teach us some
And now she's gonna pretty much do
Yeah, it's
all
all
of
about
them.
teamwork then. You gotta remember
It's all
that.
about not taking first class group tasks.
It's all about what?
Not taking group tasks in your class.
Why were they?
Obviously.
Groups are awesome.
Not the second to last one
I don't.
with sequences.
He wasn't in my class. I remember that one.
Obviously.
That one was terrible. I like that we figured that out.
They weren't that bad. Where actually, it's
All
something that she was funny, that she was nice.
You don't do a couple and that's it. You just can't do it. Like this.
Alright, maybe they're bad. Okay, number 2. So you want to start to differentiate, and I was going to kind of wrap this whole thing up with this, but with like the difference between a constant to a power and a power to a constant. And say we're going to do, wait, I mean a constant to a variable power or a variable to a constant power. So that making a distinction is important to know what to do. So like this is a constant to a variable power.
Number 2.
What that tells me is I got to follow the A to the U rules. Okay? Because 3 is like A, it's like a constant, and cotangent of x is like a U, it's a variable. So to follow these rules, the derivative is going to be itself times the natural log of the base times the derivative of the power. So negative cosecant squared x. Is that okay?
Yes.
Alright, so constant to a power, you're just writing, the derivative is the same thing, times the natural log of the base times the derivative of the power. I'm just seeing, okay, difference would be number 8 is the opposite. It's a variable to a constant, so it's switched. So this is the same old rules, nothing new. So this is the one where we take the power to the front, write down what's here, and we subtract 1 from the power. So that's the old rule, the power rule. This is the new rule, something raised to a variable power. Think about how weird, like, this would never be, if I did this the old way, it would be cotangent x times 3 to the cotangent x minus 1. What? It's bizarre. Maybe it doesn't seem bizarre to you, but it's bizarre. Okay, to number 4. This is something squared, so like being squared is the outermost thing. I'm going to deal with that first. So with normal power rule, bring the 2 to the front, times the natural log of x, subtract 1 from the power, and then chain on the derivative of the natural log of x, which is 1 over x. Or I should say, put x in the bottom and then the derivative of that on the top, which is just 1.
So that works the same way as it would with trig?
Yeah.
Okay.
Yeah. Okay, so chain rule works the same with log as it did with trig. For number 6, this part needs product rule, this part doesn't. But so if I use product rule here, it'd be the first times the derivative of the second, plus the second times the derivative of the first, and then minus the derivative of x is 1. So x over x is 1, minus 1, that's 0, so we just simplify it to natural log of x. This is an old problem, an old chain rule problem that you really didn't need any new stuff from yesterday. The power is a constant, so since the power is not a variable, it's the same old rules, bring the pi down. 2 plus sine 3x, subtract 1 from the power, and chain on the derivative of the inside. So cosine 3x times 3. Questions? And did I get them all? What else did you want to see?
11.
I just have a quick question.
Yeah, sure.
11.
Okay.
I got well, can you have a log if the base is different than 10? Because I got
Yes.
okay. Because I got an answer with like a log with different base.
So what base did you use? 2 or 21 or something?
2. Yeah.
Okay. Yeah, that's fine, because then you can have it a little bit cleaner.
Okay.
That's actually no, that's not true at all. No, I'm sorry. I was thinking you were taking the log of both sides. No, if you're going to take the derivative the way we have it, I think you have to have the natural log. Like you change, Yeah, sure. Sure.
Thanks.
I get how you got the answer, but
I don't think you can use anything but the natural log. I don't know. Okay, so first of all, understand the question. Where does that have a slope of 21? So basically it's saying where is the derivative equal to 21? That's what we're trying to figure out. So I have to take the derivative first. The derivative of 2 to the t is 2 to the t times the natural log of 2 times the derivative of t, which is just 1. And the derivative of 3 is 0. I'm going to set this equal to 21. So you did log base 2 of 2 for that?
well, I divided 21 by ln 2 first.
Okay, so that's what we do. So we got 2 to the t equals 21 over ln 2.
And then yeah, I did log base 2.
Okay, so from here, what did I do? I took the natural log of both sides, so you took log base 2 of both sides. That you can do. Yeah. I just always take natural logs, I don't know, because they're easier to write, I guess. So to get this variable out of the exponent, I took the natural log of both sides. And what that allows me to do is take an exponent to the front. So one of the basic rules of logs is that exponent can come to the front, leaving me with a gross problem, but one that I can solve. So to get t, I just divide by the natural log of 2. You can leave your answer like that. Does it make sense what I just did?
When you multiply by the natural log, then why couldn't you cancel?
No, because I'm not really multiplying by the natural log. I'm like taking the natural log of both sides. So it's not like I'm just multiplying. So I can't just cancel those natural logs. What you see for my first answer, when it says whatever or whatever, was taking this. Remember, if you have the log of two things divided, I can make that the log of 21 minus the log of 2. That's how I got that other answer. It was just taking division, it's been natural logged, and making it subtraction. That's like one of the general log rules that you learned last year and probably the year before. You don't have to know that. You don't have to know that for this problem. You have to know it for what we're going to do today, actually. But I know, right? But what Erica was saying is, like, instead of picking log or natural log of both sides, she picked log base 2. And the reason she did that is, what's log base 2 of 2?
1.
1. So that ends up being gone. So t equaled log base 2 of 2 of 21 over the natural log of 2 is basically what you had, right? That's fine. It's totally useless because you can't use you can't use log base 2 in a calculator. I could change the bases with it, but then I'd be back to where I was anyway. Well, I mean, like, not exactly necessarily where I was, but if I go change the base with natural log, am I going to have, like, forget how it works? It'd be like the natural log of this over the natural log of 2, wouldn't it?
I think so.
So it'd be back to where I was.
It ended up being 4.921.
Oh, yeah. Cool. That's the only reason to use natural logs or logs with a base of 10, because your calculator can do it. Logs base of 2, your calculator doesn't do. But logs base of 2 makes this a little simpler because this was just 1 and it went away. So that's kind of nice too. So whatever you feel like is fine. Okay, did someone say 7? I think 7. Okay, so to take the derivative of a log with a base other than e, all I gotta do is make a fraction and put this underneath of it. 1 plus x natural log of 3. I take the derivative of this for the top of it. The derivative of 1 is 0. And the derivative of x natural log of 3 is kind of a weird way to have this, because natural log of 3 is just a constant. So I probably should have that in front of the x. So what's the derivative of x natural log of 3? It's just natural log of 3. Do you see that? Natural log of 3 could have been 5. So then who writes x times 5? That's weird. It really should probably be 5 times x. Because then the derivative of that is just the number in front, just the natural log of 3. And then the only other thing I'm missing is the rule is, put this underneath, put the derivative of that up top, and then on the bottom multiply by the natural log of whatever the base is. So in this case it's 3, and those cancel. So I get the 1 over.
Should we be like the dicks this year that stare at them and just
Okay, do we have to use that word to
Do
describe
we have to be
it?
the jerks that stare at them and slam them?
Staring?
Oh crap, man.
Oh my god, please.
Leave it out.
Please.
Oh, fuck. How do I don't even know how to do it.
Looks like this one's not being put up.
It's gonna have like 27 views.
Welcome to senior year health.
Alright.
What? What?
We're gonna move on, but yet not. I don't feel I don't feel confident that like this is easy. It's not supposed to be easy. You need some practice with it. So as part of the homework tonight, there'll be some problems like this in it too, because you can't just do these and like, Corey, I'm sorry, okay? But I have 2 more examples to show you that actually are cool and that I don't think you'll find them to be that hard. Yeah.
Oh,
Yeah.
still in the shot. It like landed right where you're standing.
Alright, let's see.
Just gonna watch this one over and over.
Make a remix of it.
Done.
Auto-tune it?
Yeah.
Dubstep.
Oh, I will be editing if I can figure out how.
Get Celia on
Just
that.
stop the video and then like split it up into 3 different
Yeah,
sections.
but how do I do that?
Movie
Do you have like Movie Maker or anything?
I don't know.
Yeah, you do. Microsoft has it.
If you think I'm going through all that trouble,
Nope.
it's not.
Is it like
Does anyone have an
wrong
auto-tuner?
for teachers to curse though? Is that against the rules?
I don't know.
Depends.
I mean, I'm sure it's frowned upon by parents or something.
To who?
But I'm not saying it to anybody. It was more myself.
Oh,
Let's just pretend it didn't happen. Okay, we got 2 things.
oh, we filmed it.
So pretend we didn't film it. That's the part where someone goes, didn't film what?
Crazy problems easier.
Alright.
I don't
Part A?
believe it.
That says when logs make crazy problems easier.
What? Oh.
That's a paradox. That letter B right there.
Okay, so we got 2 little like mini things that just go on the end of all this logarithm stuff. The first one's called logarithmic differentiation. And this is what you use when you have a variable raised to a variable. So far you've seen a constant, or first you've seen a variable to a constant, and then we've seen a constant to a variable, and now we got both, variable to variable. And that's when it gets really weird. And the only way to handle this is to, before you do anything else, take the log of both sides. So there are rules for when we have like 6 to the x, that we can do that problem without taking the log of both sides. But for something like this, there are no set rules. So you gotta take the log of both sides. I recommend just using the natural log, because it's easier to write. But there's really no big reason why we're using natural log other than just it's more popular. So first thing you're gonna do is take the log of both sides. And by taking the log of both sides, the exponent from the one side comes down to the front. Then we're gonna take the derivative. So what's the derivative of the natural log of y? What do I put on the bottom of the fraction?
Natural log of y.
No,
Oh man.
Why?
just the y. And then on the top I put the derivative of y, which I have to call y prime. Okay, or dy dx, but I wouldn't put another fraction in necessarily. So now I'm like taking a derivative implicitly again. I've got x's and y's all combined. I can't separate them. if I do try to separate them, I'm going back to the beginning. So I've got to chain on or use that y prime. On the right-hand side, x, ln x, what do you do to take the derivative of that? Product rule. So I'm going to have the first term, which is x, times the derivative of the natural log of x, which is going to be, put x on the bottom. The derivative of x is 1, put it on the top. Plus the second term times the derivative of the first, which is just 1. Good? Okay, then the whole point is we're solving for y prime. We're trying to find the derivative. So y prime is going to equal, let me just fix this up a little bit, x times 1 over x is just 1 plus ln x. And then all I have to do is multiply both sides by y, so it cancels here and it pops up on the other side. As an answer, that's okay. It's just not great because it has a y in it. Like if you ever had to graph it or solve for x, I would want to replace that y, and I can really easily. What do I replace y with?
X to X.
Yep, so x to the x times 1 plus natural log of x. And that's how I'd leave the answer. Again, it's not wrong to leave y in it, but if you can replace it, replace it. What? Okay, so that's it. So if you have an exponent to an exponent, you need to take a log of both sides, take the derivative of both sides, end up with, you're going to usually always end up with a y prime over y, and then multiply both sides by y. So it's just like a little trick, a little skill that makes taking derivatives possible when it wouldn't be possible otherwise. Okay, that's one thing. The second thing is this. Actually, no, before we do that, why don't you try number, was it 12 on the bottom of there?
It is so fancy.
Okay, try 12. So 12 is a variable to a variable.
You can just cancel the x2 over x of second over x third, right?
What?
X squared and x third cubed.
Oh, for the second one?
Slashy slash.
Oh, that was a dumb thing to put. Yes, you could.
Okay.
I didn't intend to be able to do that, though. Don't tell anybody.
Okay.
What class is that? Do you know?
They look miserable, and unhealthy.
Health?
And they also look slightly dumb. I'm just kidding.
No, they do. They're not very bright.
1,000 views on this one?
I don't know how to edit video. I really don't.
Just tell Steve he's lost on this one.
Tell you what? Oh,
Just
tell
tell-
Steve is lost. Is he the only one absent? Yeah, Mac moved over. Sorry, Steve.
Wait, what did Mac do?
I was thinking like the person behind Kara's absent, but he
Oh, he's back there.
whatever makes him happy. What? You want this chair? No. I say whatever makes Mac happy. Now what makes you happy? If sitting in this chair would make Mac happy, then maybe. Right. problem like this then?
Yeah, you could, that's fine. Why not?
Because, because what we learned yesterday is a constant,
Not a variable. It just doesn't follow the same rules. I would love if it did.
I'll get over it.
Okay, so did you log both sides, bring the cosine x squared to the front, derivative of natural log of y is y prime over y. Over here you need product rule. This is just cosine of x squared. It's only the x getting squared, not the whole thing. So when I do take the derivative of cosine x squared, yes, you're using chain rule, but not for the power first. Do you know what I mean? So like I have the first term times the derivative of the second plus the second, and the derivative of the first is just negative cosine or negative sine x squared times 2 plus 2x. So then I just like rearrange a little bit. Okay. Got it? Okay. All right, so the second thing is that when logs make crazy problems easier, here's an example of a crazy problem. Now there's no exponents in it, so it shouldn't make you think automatically logarithms. The reason why logs are important is because they help you deal with exponents that are variables, and they make life a lot easier that way. So anytime we have exponents that are variables, logs help. That's like the whole point, is that logs help take variables as exponents and bring them down to the front. But in a problem like this, I don't have any variable or any exponents that are variables at all. So you don't need logs. But if you don't use logs, this would require quotient rule, and within the quotient rule you would need product rule, and within that product rule you'd have chain rule going on. So like it would be a terribly gross problem to do without logs. So what you can do instead of doing quotient rule and product rule and all that stuff is take the log of both sides. And remember all those rules from before where if you have the log of stuff multiplied and divided, I can split this all up and like expand it into one huge long like addition and subtraction problem. So before I take any derivatives, I can take the right hand side and make this the natural log of x plus the natural log of the square root of x squared plus 1 minus, because if it's division I subtract, natural log of x plus 1 to the 2/3. Which might not seem easier yet. But give it a second. I can also take any power and make it a multiplier. So I'm going to do this in one step and use a handy dandy finger eraser. This is x squared plus 1 to the 1/2. So instead of it having a power of 1/2, I'm going to bring the 1/2 to the front. And this has a power of 2/3, so instead of the power, I'm going to bring it to the front. Okay. Wait a sec so you can get it down. So it might not look easier, but here we go. Now you're going to take a derivative of everything. So the derivative of the natural log of y is y prime over y. And I'm just going to go term by term, and it really is a lot easier. So the natural log of x says just put x on the bottom, 1 on the top, plus 1/2 times the derivative of the natural log of x squared plus 1. Put x squared plus 1 on the bottom, and what goes on the top? The derivative of that, which is 2x. Minus 2/3, these multipliers just stay as multipliers. I don't need to do anything with them. Natural log of x plus 1, derivative says take the x plus 1 on the bottom. The derivative of that is 1, that goes on the top. Okay, so make sure like it's a lot of writing, make sure you understand what happened. I took the natural log of both sides so that I could expand all this out and make all of my exponents multipliers. And now I'm going term by term and taking derivatives. The multipliers in front of the logs just continue, like they don't go away, they just come down, I don't do anything with them. And then the derivative of like the log of this goes on the bottom, the derivative of it on top. This goes on the bottom, the derivative of it on top. So like the final answer, y prime, is just y times all that stuff. So times 1 over x plus these 2's cancel.
If y is equal to something crazy like that, we don't have to.
No, no,
Aww.
no. I mean, the whole point was trying to make this a simpler problem to do. So if you're going to go put y back in, you're making it not simpler. When to use this? If you have a problem, like a derivative problem that just has a bunch of crazy crap, that like would make you take quotient rule and product rule and all that kind of stuff within it. So, I mean, you'll start to notice it. You'll just start to pick up on like, oh gosh, I don't want to touch this. Let me try taking the log of both sides. So if you look at number 13 on the homework paper.
So the test strings are crazy.
No. See how, well, let's try it. You might feel a little confused because I do have a variable that's an exponent in number 13. But we'll deal with that when we get to it. As a whole for number 13, if you did that on your own, you'd have to use like quotient rule and product rule and all that. So let's try it, except, like Zach said, x squared over x to the third is going to reduce before you even start. So you can use the problem before you start, if you want. Alright, try it, see what you get. Shut up, Zach.
Now it's just square root cosine x over x e to the x.
That's actually a good ringtone.
What?
That's a better ringtone.
So it's just that, right?
Yes.
Okay, good.
Careful of your signs. If you have two things in the denominator, two things in the bottom, when I take the natural log of it all and I want to split it up, they're both subtracted. Something like this. So take the log of both sides. Again, the denominator, since there's two things in it, they're both subtracted. We got natural log of cosine, so cosine goes on the bottom, derivative of it on the top. That's easy. And then this one, like, I didn't really need to take the derivative. What is the natural log of e to the x? X. So the derivative of it is 1. So I didn't have to go from this step to get here. I could have realized that this in itself equals x. So the derivative of it is 1. Whatever, you're going to get to the same thing whichever way you do it. Okay. Okay, so just like quick recap, here's what we've got. We've got a variable to a power. We've got a constant to a variable, e to a variable, and we've got a variable to a variable. These are like our four things. This one is like regular power rule. Regular power rule. Okay, if I take a derivative of this one, it's just n x to the n minus 1. Normal, been doing it the whole time. So don't let like the new stuff screw up the old stuff. These two are really basically the same. except a to the x requires an extra step that e to the x doesn't, because you're doing the same thing for both. You're multiplying by the natural log of the base, but the natural log of e is 1. Hello? Uh-huh. Oh, Mike? Sure. That's all right. Okay, sure. Yep, bye. You really don't think you can remember to take work home for your brother?
I don't remember.
Right? Like, hello, you don't have to call twice. Okay, so anyway, these two, we're going e to the x times the derivative of x, or a to the x times the derivative of x times the natural log of a. This technically, remember, has the natural log of e on it, but it's just 1, so you don't care. And then this one requires logarithmic differentiation. So log both sides. And you just gotta look for it, okay? If your power is a constant, you're fine. If the power is a variable, it's either this, where the base is a regular number and you can go from there, or the base is a variable and you gotta do the special fancy thing. What if you have like e to the n? What do you do with that?
It's a number.
So what's the derivative of it?
0.
0. Yay, Luke, get the prize. If I had something to give you, I'd give it to you. I'm nothing. If I had a token, I'd give it to you.
Go get some tokens.
Alright, I'll give you a token. Okay, e to the n,
That's 2 in one day.
it's just a number. Derivative of that is 0. Any questions you can think of? Alright, can I borrow someone's book real quick? Does anyone have their book with them?
No, you're in my homeroom. I want to know.
I got mine.
Did I ask who's in District 6 here? Anybody?
Luke.
I should have known that's why we're in last place. Oh, not you, Kirsten. Oh, not you, Hope, either. How come our team stinks? Oh.
Are you in last?
Yes, we're in last. We're like second to last.
No, second to last is 9.
I don't know. It's close to last. That's all I know. Corey, I'm not going to speak till I stop the video.
Page 190.
7.
Am I running out of time to check homework again? Oh my gosh.
Yeah.
Oh, that's smart.
Just give us.
See, last year I assigned 1 to 39 to odds.
170.
It's so irresponsible.
Looks like a 9, but it's a 7.
Please pardon the interruption. May I have your attention, please? I have the top
Yeah, no
4
wonder they didn't do their
poster
homework.
winners. The Mr. Horner's homeroom has won, Ms. Seashon, Mr. Bush, and Ms. Berezansky. Congratulations, Mr. Horner's homeroom, Ms. Seashon, Mr. Bush, and Mrs. Berezansky. Thank you.
Those are for the posters?
Yeah.
What districts are they?
I don't know.
Yeah, that's kind of.
District 6 just did?
Mr. Bush is our.
Did you make it?
170, 13, 17, 31,
I know, but
37,
it's like 2 days
44,
worth, so
45.
deal with it.
2 days worth?
I didn't really have homework last night, really. Kind
We
of.
didn't?
We had to finish the
Because
worksheet.
I did it.
Yeah.
Does that mean that, like, I get a free pass?
You know what? Let's do it, okay?
So,
So,
not good.
Hacky sack. Too hot. Tired. Hacky sack is like really physically demanding.
bye, Steve.
Sumo Steve. I mean Jim.
Steve, I hope you're having a horrible time in Colorado.
Hi, Steve.
Steve, I hate you. Stop shooting around.
Why are you in Colorado?
Officer.
He's,
He can't answer us. It's a one-way video, actually.